A car is being driven along a road at a steady speed of 25 meters per second. So if it is starting from here, it is traveling along a straight road. It is being driven along a straight road at a steady speed of 25 meters per second. So it means that its initial speed is 25 meters per second as it's moving. When the driver suddenly notices that there is a fallen tree blocking the road 65 meters ahead, the driver immediately applies the brakes. So it means as this driver was moving, he notices 65 meters ahead that there is a tree, and then he applies the brake. So it means that from the time he applies the brakes, the distance between him and the tree is 65 meters, because the question says that when the driver suddenly notices that there is a fallen tree blocking the road 65 meters ahead, he immediately applies the brakes. So it means, let's assume, according to our diagram, at this point, this is when the driver notices that there is a certain tree here ahead of the road. So when he notices that there is a tree, he immediately applies the brakes from this point. So when he applies the brakes from this point, it means that the distance remaining from this point to there, this distance remaining is actually 65 meters before he reaches the tree. That's according to the question. So we continue. So the driver immediately applies the brakes, giving the car a constant retardation of 5 meters per second. So meaning, as when he applies the brakes, the retardation, which is the value of A, is 5 meters. Now the retardation means it is negative acceleration. So it means the retardation or the deceleration is simply negative 5 meters per second. That's the constant retardation gives. So they're asking us to find how far in front of the car does the car come to rest. Now, let's take note of this. This question is having two kinds of motion. Okay, it is all straight line motion. But we have straight line motion with constant velocity. Then we have straight line motion with constant acceleration or deceleration. In this case, we are having that the first portion of the journey, when this car was moving, it was moving at a constant velocity of 25 meters per second. And from our theory, we know that when the motion is constant, when a vehicle is moving at constant velocity, its acceleration is 0. So it means that when we look at our constant acceleration formula, all the common three formula, our acceleration is 0 when the motion is moving at constant velocity. Then from here, the velocity that was previously constant starts varying until it drops to 0, because he applies the brakes. So when he applies the brakes, now the acceleration ceases to be 0, and now the acceleration it becomes constant. Now the acceleration is now reducing at a rate of at a rate of 5 meters per second. It's reducing, it's retarding. So it means the velocity from this point to that point is no longer constant. So it means that because the acceleration, the velocity between this point and that point is varying, it means that the equations that are going to work in between this portion are the constant acceleration formula or equations which we derived much earlier in the earlier videos. So let's get started with the question. Roman 1. How far in front of the car does the car come to rest? It means that when this guy applied the brakes here and he started coming, in between here, he eventually comes to rest before he hits the tree. So the question is, how far in front? Right there. It's how far in front of the tree. So it means that when the guy applies his brakes somewhere in between here, he eventually comes to rest in front of the tree. So let's say he applies his brakes up to like a certain point there, and it is at that point that he eventually comes to rest. The question is asking, when he comes to rest, what is this remaining distance? How far in front of the tree does the car come to rest? How far in front of the tree? So it means that we're supposed to find the distance he covered. We know the distance from this point to that point, it's 65 meters. So we need to find the distance from that point when he applies the brakes up to that point when he comes to rest. So we know that while he was moving here, he was moving at an initial speed of 25 meters per second. So it means that even while he was at this point, since he was moving at a constant speed, still at this point, his initial velocity here is going to be 25 meters per second. But then when he starts applying the brakes, his velocity drops from 25 up to a certain point here. His final velocity at that point is 0. So we need to find the distance here covered when his initial speed is that, his final speed is 0, and his retardation is 5 meters per second. So we'll get straight with the working. So to get that distance from here to there, the distance he covered, we shall say v squared is going to be giving us u squared plus 2as. We are interested in getting the value of s. So v squared, which is the final velocity, which is 0, squared is going to be equal to u squared, which is 25 squared plus 2 times acceleration is -5 because it's retarding. -5 times s. S is what we are looking for. Now, of course, when we make s the subject of the formula here, we're able to find our value of s as 62.5 meters. So meaning that the distance covered from here to there is 62.5 meters. The distance he covers until he comes to rest. But the question is asking that how far in front of the tree does the car come to rest? It means we are interested in this remaining distance in front of the tree. How far does he come to rest? So it means that the answer here is going to be 65 meters minus 62.5 to be able to get the distance in front of the tree, for us to be able to answer Roman 1. So it means that it's going to be 65 meters minus 62.5 meters, and definitely our answer is going to be 2.5 meters. So it means that for Roman 1, the distance, how far does he come to rest in front of the tree? The answer is 2.5 meters. Now let's get Roman 2. Roman 2 says that if the driver had not immediately reacted and the brakes were applied 1 second later, with what speed would the car have to hit the tree? So now, with what speed will the car have to hit the tree? So again, as he was moving, he notices that the tree is 65 meters ahead. He applies the brakes. When he applies the brakes, he's able to stop somewhere before he hits the tree. Now here the question is telling us that what if he had not applied the brakes immediately? So when he does, and then he delays by just 1 second. The question here implies that when he doesn't do so, he is definitely going to hit the tree. So with what velocity does he hit the tree? So it means that since we know that before he had noticed it 65 meters ahead, so meaning that from this point, if he is to delay just 1 second later, it means the certain distance is supposed to cover. So we need to first find the distance he covers in that 1 second when he delays to apply the brakes, so that we're able to subtract off that distance and we're able to deal with our new diagram. Just for clarity, I'll redraw this diagram. So initially he moves at a constant speed of 25 meters per second. As he's moving at that constant speed, he reaches at that point and he realizes that there is a tree ahead, and the tree at that point was 65 meters ahead. So he starts retarding. The retardation is at -5 meters per second. He retards at 5 meters per second, or call it the acceleration is 5 meters per second. But now here, Roman 2, the question is telling us that if the driver had not immediately reacted to the brakes and instead responds or activates the brakes 1 second later, with what speed will he have to hit the tree? So it means that he gets to hit the tree. But he hits the tree because he delays to activate the brake by just 1 second. So the question is, in what distance is he able to travel in that 1 second? Now remember that when he was beginning his journey, he was moving at a constant speed of 25 meters per second. Since he was moving at this constant speed of 25 meters per second, it means the acceleration from this point to that point until he applies the brakes is 0, because at constant velocity, the acceleration is 0. So to be able to find that extra distance he covers in that 1 second when he delays to apply the brakes, that distance we shall denote as s is going to be the speed, which is u, times the time. The speed with which is moving is 25 meters per second. Multiply that by the time, which is 1 second. So it means that he moves 25 meters. So it means that right here he moves an extra distance of 25 meters. So when he moves that extra distance of 25 meters, remember that the speed, the tree was initially, he is able to notice the tree when it was 65 meters ahead. In the second instance, when he delays by 1 second from the point he notices the tree, he delays by 1 second to apply the brakes, he moves an extra 25 meters. So the question is, at the new point when he applies the brakes, which is after he has now traveled for those 25 meters, at this new point, how much distance is there does he have to hit the tree? Of course, to get the distance remaining to hit the tree is going to be 65 meters minus 25 to remain with 40. So meaning that from here to here you're having 40 meters remaining for him to hit the tree. And of course, while he is at that point, when he applies the brakes, the initial velocity is still the same. The initial velocity at that point, u, is going to still be 25 meters per second. And the final velocity with which he hits the tree, final v, is what we are looking for. And the acceleration is still going to be -5 meters per second. So our task here is to find the final velocity with which he hits the tree. So to get the final velocity v, still we are going to say v squared is going to be equal to u squared plus 2as. That's going to be u squared, which is 25 squared, plus 2 times acceleration, which is -5. It's negative, meaning it's retarding, times the distance. The distance is 40 meters to hit the tree, and the velocity with which he hits the tree is 50 meters per second. So that this brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.